All right. Okay. So log. Hey everybody, welcome back to my YouTube channel. Okay. We got our All right. So log equations. So we can use the laws of logs to rewrite equations to have logs in them or without as required. Now, what we could do with this first example here is, we haven't really done that yet. So what we can do is we would write the word log in front of both of these two sides. Because we know that if we do one thing to the left-hand side, we must do the same thing to the right-hand side of an equation. We can do anything that we wish to in an equation as long as we do the same thing to both sides. So what we've done here is we've taken the log of both sides. What base is this log in? 10. Why do we know that? Because there's no number down here at the bottom. Okay, so we've just taken log base 10. What we could then do with this expression here is split it. Do we see how we could split that? How could we split this log a cubed b squared? Olivia?
Never mind. I don't. Wait. You could put the 2 and the 3 at the front.
Not yet. I like your thinking, but we can't yet because that would only be if it's log of something. Sabri, what was your?
Would it be log A3 and then log B2? Like multiply them together?
Almost.
Or added together?
Yes. Why would it be added together?
Adding logs, you said it's like the log.
Yes, because remember our log A plus log B rule was log of AB. Yes? Okay.
Hi, Miss Rose.
We're recording.
Gideon!
Oh my, Gideon! It's over there.
We've got log of these two things are being multiplied together, aren't they? So we can separate them by saying this is now
I know, we can divide.
log y equals log of a cubed plus log of b squared.
Wouldn't you just divide them?
What? I did that.
All right, so remember we had the rule from this lesson that if we had log of a plus log of b, it's log of ab. Where they're multiplied together. Yeah, so if we need to split things, we would have an addition sign in between them. Okay, you all happy with that now?
Yoki doki.
Yeah, I'm with you.
Excellent. Now, Gabrielle,
Yeah.
what do we do now? You said something before.
We take the 3 and the 2 and put them to the front so they can get multiplied.
Right. So we would have log y equals 3 log a plus 2 log b.
Yeah, because
That's the end.
What do you mean, the end?
We did nothing becomes 6.
But then
Why not?
simplify it and put 5 log B.
Then should be 5.
No,
No, you've done some.
no.
But what if it had been 3 log B plus 3 log plus 2 log B? Then would you simplify?
Yes, you could do that. But you would have had something different up here to start with anyway.
Yeah. Okay.
Wait, so why can't you add log a cubed plus log b squared? Is it because of the...
Because they're different values here.
Oh, okay, but... I'm kind of confused because of this, where they've got a and b as the base.
Oh, I apologize.
Sorry, that's why I think that's what Gabrielle. Okay, that's okay.
Okay.
I know that, yeah.
So we just do it like that.
Yeah, we can just leave it like that.
Thank you.
What's the point of that? Not really sure, but hey. So we've got y equals m over root n. Okay? So we could take logs of both sides of this one. So we could write log y equals log of m over root n.
That's it?
Not yet.
For the
Yeah.
first one?
Yeah.
That's okay.
Wait, that's it?
Wouldn't
What?
it be a log
For the
as
first one, we're
divided
done.
by?
We're done with the first one. Can't you
That's
do
it?
log m and then log square root of n?
Oh, I haven't finished this question. Sorry, I haven't finished this one. I
Yeah,
finished
that's
this
what I was
one
talking
here.
about.
You're not going to be able to hear me in a minute when I'm just saying this one. I'm pointing. We'll finish this one. We're now going to carry on with this one.
We finished A.
We're finished A, we're doing B. So we've written log, all we've done is write log in front of both of those two sides. And now we're going to do something similar to what we did here. We had two things multiplied together here. And what's happening here?
So
Elena?
would you do m log plus, oh, never mind.
Olivia?
Log y equals log m subtract log square root thingy m.
Lovely. Elena, do you see why we did this?
No.
Okay, so what was happening here to my a cubed b squared? What was happening to them?
They're going to be added. No,
No.
they're times.
They're being multiplied because they're next to each other, yes? Yeah. Okay, so when things are being multiplied, we can split them in log statements, and they would then become plus log statements
Oh.
separately, yes? And so what we're doing is we're using that rule in reverse, if you like. So if you've got log statements added together, we can combine them, but if they're already combined, we can split them by having a plus
Oh, so
statement
they're
in
being
between.
divided and you can.
So these ones were being divided, so we would subtract them.
Okay,
Okay?
thank you.
Excellent. Now, the only thing that we don't really like here is this square root. So what do we know about square roots?
Wouldn't the square root go around the log as well?
No,
Okay, good.
Why not?
because this here, this was log of a cubed, this was log of b squared. Like the log just goes in front of these two things here.
Okay.
Mia?
It would be half. That's the word.
Let's go with what the square root is to the power half first. Yeah, so we're happy with that. So this would be log y equals log. Oh, that doesn't say log. Minus log m to the power 1/2, and then because it's a power 1/2, as Mia just said, that half can now come in the front. Shush now, it is totally
that's why I
m.
Oh, okay.
Darn it! I heard you say that, and I wrote it.
That's a very clear n. So log y equals log, yeah, that's too hard. M minus 1/2 log n.
Question.
Whoa!
Yeah.
What the heck?
This is just me. How did you get to half again? Oh,
Okay,
I got it. Never mind. I'm good.
okay, good.
I don't. How did you get the half and
Because
why?
usually it's like the square root of something that's like it's timesing itself. Yeah. In my mind, I didn't see why, but it's like if you divide it by
So if I had the cube root of a number,
just it makes sense in my brain.
so a new question, if I had the cube root of a number, what power would it have? What equivalent power would it be if it was the cube root?
1/3.
1/3. If I had the fifth root of a number, what equivalent fraction would it have, Gabrielle?
I don't know.
So we had the square root was a power of 1/2. The cube root was a power of 1/3. What would the fifth root be?
A fifth? 1/5?
Yeah, 1/5. So whatever the root is, remember that's the denominator of our fraction. So fractional powers and roots are connected in that way.
But how'd you get from an infinity to out the front to be like -1?
Because remember the rule is if you had, like we had here with the 2, we know that if we've got powers on our terms, those powers can come in the front. So I just took it step by step. So I changed this to be a power first, and then my power can be written at the front.